It's my pleasure to introduce this Building Your Development Pipeline breakout session. I'll be your MC. My name's David Butler. I'm in product marketing at Docker. But we have some great presenters. This is a great topic. I love this. Laura Tacho from CloudBees. She's a director in engineering, also a Docker captain for many years. So it's great to have Laura here. And we also have Olivier Pomeroy from the UK, Docker in the UK. He's a solution engineer, and they're very excited to talk to you about building a development pipeline. So welcome to the stage.
Hello, everyone. Welcome to Building Your Development Pipeline. This is Olly. He's a solutions engineer at Docker. I'm Laura. I'm director of engineering at CloudBees, mostly working on CI/CD stuff. Olly has a lot of experience working with customers and seeing this in practice. So what we're going to try to give all of you today is an overview, starting with build all the way to deploy, of what the process is of getting a pipeline up and running with Docker, deploying into some environment that's running containers. Let's just get started and talk about what is a pipeline, and when we say that, what are we actually talking about? When Olly and I talk about pipeline here, what we're talking about is not a YAML file or a particular syntax or any file at all. We're talking about a process. The pipeline is a process, a set of processes to get your code from development machine all the way into production. There's a lot of different components that go into a pipeline. So there's building your container images. You have to do some automated testing, security scanning, and then finally getting that image promoted into your production environment or any other pre-production environment that you might be using. Throughout this talk, we're going to focus on 4 main areas and dig into some high-level stuff and then some finer details into all 4, starting with build, going to test, talking about securing your images, and then finally getting to deployment. So let's start by asking the question, why use containers for your pipeline in the first place? And there's a couple reasons, and I'd like to group these reasons into kind of 2 main themes. One reason to use containers in your pipeline is about all of the things that happen inside of your container. We love Docker, we love containers because it gives you a very consistent, reproducible, reliable, predictable environment, because all of your environment stuff is declared in that Docker file. So you kind of know what you're getting, and you can move that Docker file and move that image across different environments and get more or less the same result. You can also modify it because everything is described in a Docker file. There's no sort of mysteries. Everything's right there in the file for you to look at and modify. This makes you very efficient as a developer, but also looking across your organization. If you're interfacing with other teams like operations teams, you have those artifacts that you can pass from team to team and have everything very explicitly declared in your Docker file, in YAML files, and all of those application bundles. So that's what's inside the container. Another compelling reason to use containers for your pipeline is what goes on outside of the container in systems and workflows. So since containers are super lightweight, they're fast to boot, they're really isolated and give you that reproducible environment, you can use those features to give you workflows that are really great, especially for pipelines. So running one container takes milliseconds. What about running 100 containers in parallel? Then you get 100 times the workload in the same time. You can have a much better virtualization density and get more out of your infrastructure. So parallelization is something that we'll talk about and a really common thing in your pipeline when you're using containers. One thing, though, is that Docker can do a lot of great stuff for you, but there's no shortcuts. And Olly and I see a lot of customers that start to use Docker, people who are brand new to Docker, and they've maybe heard a bit of the hype of like, Docker is going to solve all of your problems for you. It's going to be great. How many of you have heard that? It's pretty true, but in reality, there's no shortcuts, and you still have to be a good engineer, a good architect, and make sure that your applications are architected in a way that is sound and responsible. So following things like 12-factor app guidelines, pinning dependencies, paying attention to the size of your images, understanding how much space it takes up on disk, making sure that you're performing security and vulnerability scans. These things Docker can make easier for you, but Docker won't do it for you. So you still need to bring kind of your end of the deal here and uphold your responsibility as a developer. Docker can certainly make it easier for you. So let's talk about that number one stage, building images in a pipeline. So again, we're talking about pipelines as a process, and the first process is taking your Docker file and just building the image so that when you have that image, you can do something like do security scans, test it, and then eventually deploy it to production. However, there are some issues that you'll run into and a couple common problems of using containers as part of your pipeline for building images. Some of us work on really, really big, fat, monolithic applications that are running inside of a container. So when we have a build agent, we might need to have a super huge build agent that requires a ton of CPU for that huge job, that huge application, that huge test suite. But when that's not running, those CPUs are just sitting idle. So that's one common problem. The other common one is that we don't have standardization across the many different applications that you might be using day to day. So in your build agent, you're just going to kind of shove every single package in there so that you have a one-size-fits-all. That's also not super efficient. There's a couple solutions and a couple patterns to introduce you to that address both of these problems. So number one, on-demand build agents can help solve that problem of having an agent sitting idle. If you have them on demand, you can reduce that idle time. And then not standardizing tools, you can maybe give a build agent image for everyone. But the question that both of these things lead to is this secure? Because security is a huge part of your pipeline and making sure that you're only shipping the code that you want to production. Let's talk about a couple different styles of actually building the image in that pipeline. So when we're talking about security, we want to make sure that not only the image that we produce and ship to production is secure, but the way that we do it is secure. So building an image can introduce some security questions, especially depending on the style that you do it. One common way to build an image inside of a pipeline is using this thing called Docker in Docker. So you're basically running inception of Docker inside of a Docker container. This is a little bit what it looks like. You can run a container, have a special Docker and Docker image, and then inside the container have access to the Docker daemon. That's one way to do it. You can see here I'm running an image, and then I can say Docker images, Docker PS from inside of the container, and then control my build process that way. The other style of building images in your pipeline is via a mounted socket, and this is specifically for Linux, where I'm going to mount the Docker socket into a build container so that I'm not actually speaking to Docker from inside of a container. I can speak to it, kind of control it outside, but I have that direct access to the daemon in order to build an image. So here I'm just running a Docker container and mounting the Docker socket from the host into the container and then being able to control it, and that's the way I'm going to build my image. I can run things like Docker image, Docker PS, and get output just as if I were natively interacting with the Docker daemon. On Windows, it's pretty similar. You're going to mount the pipe. Similar concept, just a slightly different syntax, but it's possible on both Linux and Windows. This comes to the security question. Is building an image in either of these strategies or either of these techniques secure? When we're running Docker in Docker, we're doing something called -- privilege. We're giving access to the container to do pretty much everything that the host can do. This is problematic because you can't trust everyone. What if there's untrusted code running? What is the damage and what's the blast radius? With a mounted socket or pipe, the blast radius is maybe similar because this container can control your Docker host completely. You're just giving it access to the Docker socket. Any security that you've applied to the socket is pretty much bypassed, and this container can do anything to your Docker host, which is also not ideal. So in the mind of security, there's a couple ways to get around both of these problems. Docker in Docker is great, and it's used by many popular CI tools for building. Coming out soon in Docker CE and EE 1903 is rootless Docker. There's also some really interesting rootless building daemon projects. So, for example, BuildKit, which will be part of the Open Source Summit on Thursday, is a new, interesting way to build Docker images that in the future is going to kind of be that underlying layer used by Docker. You won't have to necessarily understand how it works, but you'll benefit from it. There's a project called IMG, or Image, from Jess Frizzell. There's also tools like Canico that kind of help you build images securely in your build environment. The drawback to these is that you do need to be on a very modern tool set in order for these tools to be functional. So I think with these are all, you need Kubernetes 112 or above in order to use them. So if you have some restrictions there, this might not work for your particular use case, but definitely worth checking out. Mounted socket or pipe is also really popular. And the way that people use this safely and securely is just simply by having a dedicated build host or a dedicated build cluster where you are mounting the socket or mounting the pipe. That way you can kind of control who has access to what, and making sure that you're running trusted code and keeping everything kind of locked down. Olly is going to take over now and give you a little sneak peek into what this looks like actually in practice. So we've covered the theory part, and Olly has prepared a wonderful demo that I'm incredibly excited to see. No pressure. We didn't do a sacrifice to the demo gods, so.
Yeah, I didn't have a sticker.
Yeah.
Next time.
Next time. I have some in my badge, but I don't have them with me. I'm not sure they would like us defacing the podium either.
Next guys might not like that one. OK, so at this part, we're going to kind of do a quick demonstration on how to use containerized build agents. So what kind of tools have I got available? So the first thing that I have, this timed out, but I'll log back in, is I have the CloudBees Jenkins distribution. So that's my pipeline tool here. I'm using Jenkins. All of this is running on top of Docker Enterprise. So I have a Docker Enterprise cluster supporting this, and I have a registry for my container images, and of course, I have a sample application. Now, those are kind of the bits and pieces. And one thing to note here is, and one of the key things we just talked about, is that there are no build agents sat there waiting. I haven't got any idle nodes. I haven't got any kind of idle CPU agents. It's all kind of clean. So first thing I'm going to do, I'm a developer. I've kind of checked out that code. It's sat here locally. That one. What I'm going to do is I'm going to make a change to my application. Just something to kind of start the job. I just kind of got a hola. Let's change that out to, I don't know, hello, DockerCon. Cool. And so a developer, I've made my change to my application. I put that into source control. That's basically how all pipelines normally start. A developer checks in their code. Cool. So what we expect to happen now, we should actually have a new commit. Cool. Quick refresh of that. Great, we have a new commit. Hopefully Jenkins should have been told. I've just been told I've got a new commit. I've actually committed straight to master there, but I have a new commit, and it would have started off a build job. You can see straight down here at the bottom, a build job's running, and the first thing that's happened, it needs an agent to do that build job. Now, right now, I'm using the Docker plugin, so Jenkins has talked to Docker Enterprise and said, hey, I need somewhere to start up an agent. I need somewhere to build my container image. What I'm trying to do here is build a containerized version of that application. I'm actually using Windows for this demonstration. So if I switch to Universal Control Plane and I switch to running containers, hopefully you would see in here that a new container was started a few seconds ago. It's been started on the first one of my Windows workers. And just to kind of answer the question, how am I building a container inside of a containerized build agent? There we go. I've mounted the Docker pipe. So, and it's kind of Laura's two scenarios there. I'm doing the second one. I'm mounting in the pipe into my build agent. So I now have somewhere to use Docker. I'm able to build a container inside of a container. So that should have happened dynamically allocated. We should have had a build job, quick check on its progress, and quick look, see what's going on here. Checked out my code. did a Docker build against that pipe, and hopefully pushing it all the way to the registry. Success done. A quick refresh. Maybe a few seconds ago, great. Got myself a new container image. So there you go. You've seen, as a developer, the second I check in my code, I've dynamically given myself a build agent. I've built the container image in my build agent, pushed the image to DTR, and then cleaned myself up. I would delete the build agent. My work here is done. I'm ready for the next commit. You can see now we're clean and good to go. Cool. Back over to you.
Great. Thanks, Olly. So now that we have a build image or an image built, we can start to perform tasks as part of our pipeline on that image. And the first thing that we want to do is run an automated testing suite. So the developer experience here is that as a developer, I'm going to do some work locally. I'm not going to commit directly to master. Then I'm going to, just a gentle scolding, it's fine. So I'm going to commit up to a branch, or maybe to master. Maybe it is a master commit. And that's going to kick off an image build. Once I have that image, I have the code that I just modified, and then I can start doing things like testing and running security. So next up is testing. And this is following that build once, use everywhere. I only have to build it once. I don't have to repeat that process for all the stages of my pipeline. I can just continue to use that same image and be really efficient. So the Docker file in this scenario truly becomes a shared artifact that's sort of produced at one point and then shared not just throughout your pipeline, but potentially to other teams as part of your software development lifecycle. You can do things like local testing during development, which we didn't show here. We just showed the sort of remote example. You can run standalone unit tests. You can do browser integration tests, and then eventually promote that image up to QA or to staging or to eventually production. One thing that is important to note here is that for a lot of us, this idea of like using the absolute same Docker file everywhere may not be reality, unfortunately, because dev and test can be really, really different. Some of us have optimized optimized development environments with all your debugging tools. You don't necessarily need that in testing. So one strategy that you can have is just to take sort of the important bits of the Docker file and create a shared base image for that application that can be used as the base for your development environment, but then also used as the base for your testing environment. That way your testing environment doesn't need to necessarily have all the debugging stuff. You can add that just development environment depending on the tastes or particular tools that you prefer to use, and keep things nice and tidy in testing. One other practice that's pretty common is having a specific docker compose.test.yaml, docker compose.dev.yaml. So trying to reuse as much as you can, as much as practical, but also being realistic with the fact that sometimes these environments can diverge for very good reasons. It might have just like the overhead of writing one more file or keeping another set of instructions in your README, but generally the efficiency that you gain is well worth it. So in practice, a sample integration testing pattern using Docker Compose might look something like this. I have on the left side of the screen a docker compose.yaml file. I have a couple services. This is for that dogs versus cats voting application that's often used at DockerCons if you're familiar with that from previous keynotes. We have a voting service. It has a build instruction, some ports, some depends on network, et cetera, and a couple other services to help keep that application running. On the right side, I have more or less the same, but I'm adding another service called test, because this is my docker compose.test.yaml. So what that test service does is that service is specifically created only to run the tests, and it's going to depend on the whole application stack, which I can more or less just copy and paste from my development file. So I can create with this docker compose.test.yaml a one-off application environment by mostly reusing everything from my dev environment and then running my testing on top of it in a pretty clean, straightforward way. To go further on this point, a lot of these configurations are also able to be used directly in a lot of CI/CD tools. So we use the example of Jenkins here. You can use your Docker file and kind of have that application definition run throughout your pipeline. There's a lot of other options for you, whether you want a hosted SaaS, maybe with Circle, CodeShip, Travis, Azure DevOps. There's supported on-prem, so we talked about the CloudBees Jenkins distribution using Jenkins here, but certainly other on-prem self-managed options. You can reuse your Docker Compose files, reuse your Docker files, and then pure open source, there's Docker support, Jenkins, JenkinsX, just being able to kind of reuse, build once, use everywhere, not having to do a lot of duplication. Olly likes to joke that all of these companies paid him $5, so there's lots more on here, but they didn't pay him. So if you'd like to rectify that and get on the next round of this talk, just talk to Olly afterwards. He prefers pounds, though, because he's from the UK.
No receipts.
Yeah. We talked a bit earlier about how containers can help you parallelize your workloads because they're so fast to boot. So one theory to share with you here and one tip is to use that parallelism to your advantage by splitting work in your testing across multiple computers, and in this case, a computer is just a container. So think of your container as just a process, and that way you can run multiple parallel processes. They're all just running in containers side by side, getting a lot of virtualization density on that infrastructure that you're paying for. If you need to improve performance, you can just kind of scale up, add more containers. And then all of this can be pretty easily managed declarative style in a YAML file in the Docker ecosystem with the tools available in the ecosystem. In practice, this is not something that you necessarily have to do by yourself. Because it's such a powerful pattern, it's often been productized or added as a feature to many popular CI/CD tools. So Jenkins files support parallelism, CodeShip steps file, GitLab, etc. Parallelism is there for you. It's just a matter of kind of writing the YAML. A couple use cases that might not be super apparent about using parallelism would be testing against a matrix of versions. So that's a really interesting way to use containers and parallelism to test across sort of a lattice of support. You can cross-compile on Linux and Windows at the same time. And then running integration tests against different browsers is another really good example of using containers in your integration test suite. One word of caution here, it's really easy to get a little bit carried away with parallelism. Make sure that you're not putting your deploy step as a parallel step to your testing. I've seen lots of users make that mistake. Just make sure that your YAML is really aligned and that you can see where everything is indented. It can be a really easy mistake to make, but have really disastrous consequences, because what happens then is you deploy without needing all the parallel tests to finish, and you can end up in a pretty bad spot. So learn from my mistake, lots of other people's mistakes, and make sure you're paying extra attention. Here's an example of what a Jenkins file would look like using declarative pipeline, running cross-compilation on Windows and Linux side by side in parallel using containers. So we have these build stages, and then in the Jenkins file, have them split out to say, let's take advantage of parallelism by compiling on Windows, compiling on Linux, at the same time using containers. Another great example of using parallelism to your advantage, I mentioned before, testing against multiple browsers and devices during integration tests. So Selenium Grid is exactly this, if you're using Selenium for browser testing. There's a style of doing it. You have this thing called the Selenium Hub, which is this sort of world-looking thing. And basically what you do is just split out all these different permutations of like Firefox on Ubuntu, or Safari on iOS, or Safari on macOS, and you can test all of them in parallel. So your test suite doesn't need to get longer, but you end up with more coverage and more reliability thanks to parallelism. So that gets us all the way through tests, and then Olly is going to talk about securing the images that you've built and test so far.
Cool. Thank you. So as you saw kind of through the first demo and through that, the testing phase, a lot of automation, a lot more power going into developers around what they're checking in and then what's being built inside of your container images. So then it kind of leads to the question, how can security or operations teams get some visibility into some of this stuff, start to apply some of their controls, some of their standards on top of all the automation processes going through the pipeline? So kind of let's kind of start at the first question that gets asked. Kind of, I've downloaded all these container images, I've built all these container images. How do I actually know what's inside? Like, how do I know there's a data package in there, like a vulnerable package in there? How do I actually know what I've embedded? And if you ask this to a developer and their answer is, well, we got it from the Docker Hub, it had a blue tick next to it, like, it should be okay. Sad panda, like, that's not security.
Yeah. You're going to have a bad time.
Yeah. And like, kind of, how has this problem come about? Well, if you look at the old world or how we used to kind of develop applications, devs would own the application code, operations would own the infrastructure, the operating system, and probably the framework or that middle layer. In the new world, in containers, that middle layer is now inside of the container image, okay? And where that kind of boundary is, developers normally end up owning that container image. So then the question becomes, who's giving this TLC? Like, who's looking after that middle layer for you? Or at least, how can somebody in security or operations get visibility into that middle layer? Now, I kind of went on the Docker Hub to try and find an example of this. The example I've picked happens to be Oracle. Nothing specific, not an attack aimed at Oracle. It was just a really good example of what this looks like in practice. And I went up to the Hub, and I grabbed the Docker file for their WebLogic container. And if you kind of look at this with the simple question, am I running a vulnerable version of OpenJDK? You can't tell. You can't tell from just looking at the WebLogic container. So you go, all right, I'll hop one layer back. The base image in that was server JRE. Let's go check that one out. OK, scroll through it. Still no mention of what packages are installed. Still no visibility about what's actually being embedded inside of my container images. I can go one layer further, actually look at the Oracle Linux base layer, and it's a tarball copied into Scratch. Now, I don't want to pick on Oracle. It's just a simple example. But this really is sad panda. Like, I have no idea what I'm embedding inside of my container images. I have no idea what version of OpenJDK I'm in there. Like, what am I exposed to as a security team? So what can we do? The ecosystem right now has got quite a lot of mature tools around there on image vulnerability scanning. Like, this particular screenshot's from the Docker Trusted Registry. We'll look at that in a bit more detail in a moment. But there's a lot of different tools out there today that can scan container images, inventory out all of the embedded binaries and libraries, and compare those against CVE databases. So after images have been built, we can actually start to see what's inside and kind of compare that against vulnerable databases. But then the kind of question becomes, how do I actually control this? I've kind of identified some container images that are clean. Maybe the operations teams produce base images for us to use. How do I enforce that the developers use the official base images that I create? And how do I make sure that developers conform to the best practices? Like, if you're in Sebastian's session, there's some good best practices there on Docker files. How do I actually embed that inside of my pipeline? And the answer is the ecosystem's got tools for you. Whether that's linting and kind of trying to do kind of regex matches on your Docker files, or whether that's actually policy engines. Like, I'm personally a big fan of Anchor and Anchor's engine, and there are a few others out there, but this is where you can actually start to define policies on what your Docker file should look like, and then as they go through the pipeline, compare against those policies. And in kind of the next set of demonstrations, I'll show this in action. One of the other things and one of the other tools that we have to our in kind of our kit bag is signing. Inside of Docker, well, actually out there in the community now, we have Tough, the update framework, which is the specification for signing software. And we have Notary, which is Docker's implementation of that specification for containers. We can sign container images to say, this one's good to go, please use it. And then you can go to your clusters and say, please don't start this container image if it does not contain signatures. And you can kind of give the keys, if you will, to security and operations. Like, they can control what gets signed. They can control what gets rolled out. So if your pipelines are pushing images out all the time, it doesn't have the magic key, it's not going to get started on the cluster. And you can see here some of the error messages from Kubernetes or from just the Docker engine when you try to start containers without signatures. And all of this can be automated through your pipeline. And I can't really stress that enough. Don't feel that you have to do all this security after the container image has been built. Automation can happen as you go through. Whether that's automating the image promotion, so when a container gets built, push it to a development repository, start to do some of the testing on it there, and don't promote it unless it's clean. Or whether that's integrating webhooks into your registries and kind of notifying different tools at different stages as you work through the pipeline. OK. Handing it back to Laura around how we can start to deploy the applications built in the registry into production.
Amazing. So at this point, we have built our image. It has passed all the automated tests. It has passed security requirements, so whether it's been signed or we run it through a static security vulnerability scanner. Now we're ready to deploy. We're ready to promote this to production. So there is often a little bit of confusion around what is continuous integration and what actually is continuous deployment. I think we often tend to sort of lump this together. And even I work in CI/CD, so it's very important for me to understand this. But before I was really deep in that world, I probably couldn't describe necessarily the difference between CI and CD because it all just kind of seems the same. So just for sake of simplicity, so we have common vocabulary, CI is all of the kind of integrating the code, testing it, and then once it is sort of ready to go into promotion, that's where the CD part of it picks up. So all of the building, testing, securing, we're talking about CI, and now we're going to venture into sort of CD or even release automation land by talking about creating the deployment and then actually deploying it into our cluster. So whether that's a Kubernetes cluster or a Docker EE cluster. How do we do this? We can do this in a couple different ways. Some of the ways are processes with our CI/CD tool, for example, Jenkins. And some of them are actually the responsibility of the orchestrator or the deployment target themselves. So these lines, as the developer tool world continues to evolve more, and developers have more tools, these lines get really, really blurry. And it's kind of hard to understand what's your responsibility, what's the tool's responsibility, what's the orchestrator's responsibility. It can all get a little bit muddy. This is one of those areas. So when we're talking about deployment, a lot of these deployment techniques are actually built in not to the pipeline tool, but to the orchestrator itself. So for example, Swarm or Kubernetes have deployment techniques baked into them. You don't have to write them yourself. They're just sort of there for you, and a lot of them are sensible defaults. That means that your pipeline does not need to control things like, for example, rolling updates. What it does need to do, though, is make sure that it's communicating status back to you as the operator and as the person who needs to understand exactly what's going on. So one deployment strategy that we'll talk about is one that might be very familiar to all of you. It's called the rolling update. This strategy is updating containers either one by one or in groups of a certain threshold so that the application has no downtime. That means it's possible for two different versions of the software to be deployed at the same time while that update is going on. So it's not completely sort of foolproof and without involvement. It is a pretty common way and a pretty safe way to have no downtime deployments. If you're not familiar with it, it looks a little bit like this. I'm going to have my current version, I think that's a sort of bluish purple, and then have my green version coming out, and just sort of one by one in this case, roll it out until everything is successful and running in production. This could be really complicated, but fortunately for us, it is just the default for lots of orchestration systems and lots of deployment targets. So Swarm and Kubernetes do it for you. No need to custom build this functionality yourself, all that control flow. In Docker, in Swarm, there's a preference you can set called update config. So you can set things like delay, failure ratio, parallelism. That's like the number of groups. So I have that set to 1. Auto rollback is also for free with Swarm. It's just the failure action is rollback. So in case there's a deploy that goes out, the container starts and it's unhealthy for some reason, Swarm's just going to roll that right back for you. You don't need to necessarily monitor it or babysit that deployment. In Kubernetes, kind of the same deal. We have rolling update. That's the default. We can do things like max surge, max unavailable, set all these sort of little buttons and levers. Read the documentation. It's incredibly thorough in both of these cases, and a really, really useful thing that's sort of out of the box written for you. Great. So that's our software supply chain. We went all the way from putting new code into your SCM, so committing to GitHub, and then talked a little bit about actually deploying to Docker EE. And to wrap this up, we're going to show you what that looks like in practice.
Cool. OK, we have about 5 minutes left, so one big end-to-end demo showing how an application can kind of start out its life in source control, go through the building process, go through the testing process, and then kind of end out into production. Once again, a similar set of tools here. So make sure this isn't timed out, but CloudBees Jenkins is our distribution. Docker Enterprise on a universal control plane for the run component. The Docker Trusted Registry to store our container images. And I have a new application running in source control. I'm more on the infrastructure than the developer side, so this is all I really could produce. Hey, you can click the whale, so it's a good enough application for me. So that's going to be what we're going to work on and kind of go end to end from development all the way into production. So we're starting out. I've got my Jenkins. I don't have any build agents. I've got a few pipelines defined. So switch to the second application and make a quick change. So quick change here, maybe. Well, there we go. Hi. DockerCon. I've overwritten half of that, but that's fine. Cool. Check all that into source control. Once again, sorry, Laura, we're going into master again.
Yeah, it's OK. Educational purposes only.
And that should be the start, right? Developer's checked in his code. That should absolutely be the start. Source control's taken it. It's notified Jenkins, hey, I've got a new commit. Let's start out on the build process. So you can see here that I have a build in my queue. I would have actually checked in a Docker file. So inside of here, I have a Docker file. That's checked in, and that's actually good to go. I realized I've messed that up a little bit. So let me just copy that back and reset. I thought I had done this. Let's go again. Let's start second build job. That one's no good. I knew we should have done stickers. This wouldn't have happened with stickers.
Yeah, that's true. We didn't do the demo God Sacrifice.
All right. So let's see what happens right now. So yeah, I realized I didn't check in something, so I've just reset myself. Cool. So hopefully we should cancel out 24. 24 wasn't interesting. But 25 is kind of the one that I've just checked in. 25 is what I'm working on. And right now you kind of see that I'm building my container image like I did before. I'm spinning up a build agent. This particular build agent is running on Kubernetes. So I have a quick look in Kubernetes, switch to the Jenkins namespace. And we should have a pod being built. Excellent. So I've now dynamically brought up a Kubernetes pod, and that's where I'm going to do my container builds. It's going to push it off to DTR, as expected. Once an image has been built, we want to push it off to DTR. We want to have a centralized place. And then I'm going to use Anchor, in this case, to check that the container image that I've built complies to my corporate policy. Like we talked about before, how do I make sure that this meets the corporate standards? So hopefully, if I kind of check in on this a little bit, give it a couple of seconds. Good. In a minute. Almost there. Cool. It failed. And the question is, OK.
On purpose. Don't worry.
On purpose. Why did this fail? And Anchor, in this case, manages actually to give us a nice little bit of a report. It's told us the build failed because the developer didn't specify a health check, the developer didn't use one of our corporate images, and the developer is actually trying to run his container as root. So right now, natively inside of my pipeline, I've got immediate feedback to the developer that this image is going nowhere. We're not even going to get to testing. You've failed to comply. Go back and work on your Docker file, and then come back again later. And this is here for the developer to see right inside of the pipeline. So I've seen that as a developer, and you can kind of see what I'm about to do next. But I'm going to copy back in a Docker file which complies. So I'm now using an official kind of corporately assigned base image. I've specified a non-root user, and I've built myself a health check. So now I'm complying. Hopefully now when I try to check this in, we can start to go a bit further on the pipeline. So working demo, hopefully.
While Olly's committing that, I'll just mention what I discussed before with the automatic rollback and then detecting whether a new deployment is healthy or not relies on the health check as that mechanism, which is why it's against all these companies' corporate policy to not have that health check in the Docker file. Without a health check, there's no way to do the auto rollback because we don't know what constitutes a healthy container.
Cool. Right, so that's now going to go through the process, and it's going to spit out a container image for us in our registry. Inside of our registry, you may have saw this before, but we have vulnerability scanning. So we're able to actually look inside of those container images and see kind of what is contained inside of each layer. So if I had taken that Oracle image, put it inside of here, you would have seen all of the binaries that I had embedded and their versions. So if I had taken that Webster image, you would have seen the OpenSSL version straight away, straight in the registry, and you kind of need to kind of get that information right up front. You can then build automation off the back of this. So you can then build yourself a promotion policy to say, if it does not contain any critical vulnerabilities, take it out of a personal developer's repository and move it into testing. When images get moved to testing, that starts off the next pipeline job, and hopefully you should see testing started because the image complied, it didn't have vulnerabilities, we can now move on to the next phase. And you can kind of start to see how we go through this process of building and then testing our container images. I'm, once again, not much of a developer, so the testing's here reasonably straightforward. I'm literally going to stand up the container. Does it work or does it not work? But it's kind of showing how all of this can be seamlessly triggered from security, having a look at my container image and making sure it complies. Hopefully, once it goes through testing, we'll move through deploy. I think we're going to run out of time to not go through the deploy side. But once again, Jenkins would have talked to UCP, triggered the deploy, and started to roll out a new version of my application. Hopefully, you would have seen me go through that whole pipeline. You would have seen me new code line in source control, go to Jenkins, push to the registry. If there's no vulnerabilities, move to testing. Once testing passes, sign it, put it in a production repository, and get ready to do the production rollout. Thank you very much. Please rate us and share us. Please rate on the app and follow us on Twitter for more information. We're doing questions at the front if you have them.
Yeah.
Actually, on the side, questions on the side, but a round of applause for Laura and Olly. Excellent.